Hello everyone, this is Sivaraman, Department of Aeronautical Engineering from Hindustan College of Engineering Technology. Here I am going to teach you about the classifications of internal in this module. Coming to the classification of internal, so there are many factors which is classifying the internal. The factors are circuits, speed region, test section, then based on purposes. Let's see one by one. Based on circuits. Internal can be classified into two types based on circuits. One is open circuit internal, the second one is closed circuit internals. Open circuit internal. The concept of open circuit internal is very easy to understand because the name implies itself, which is the ventilator is open to the atmosphere. Here you can see the both ends of the ventilators are open to the atmosphere, right? So the test section will be open to the atmosphere. The flow which is coming from the atmosphere will be going into the test section through the open section here. Here from the driving unit, the flow will be going out of the ventilator. The next one is closed circuit ventilator. So closed circuit ventilator means which is very opposite to the open circuit ventilator. Here nothing is open to the atmosphere, so will be the closed section you can see in the picture. Then the pressurized air will be given to the wind tunnel by using the external devices. These vents will be used here for deviating the flow into the model. There are some types in closed circuit wind tunnel. The first one is single return wind tunnel. The second one is double return wind tunnel. The third one is annular return wind tunnel. Single return tunnel. The concept is very easy, as I already told you. Single return, that is the flow which is coming to the test section by using some external devices, then the flow will be going, that is returning to the model in a single way. Okay, if the flow is returned to the model in a single way, or the flow which is continuously going inside the system in a single way, that is called a single return wind tunnel. The next type is double return wind tunnel. In that single return wind tunnel, there is only one way. The flow will be continuously going inside the wind tunnel. So here you can see this is our test section. The flow will be going like this, and the flow can go like this also. So here the flow is going in a double way. So that is, it is called as double return wind tunnel. Then annular type. So annular type is same as a single return wind tunnel, but here the returning section will be in circular shape. So here you can see the circular shape at the returning section. So this is our test section. The flow which is going out of the test section will be in a circular way. So annular means the same as circular. So the same meaning, annular means circular. So here you can see the circular shape at the returning section. So that's why it is called as annular type return wind tunnel. The main difference between open circuit wind tunnel and closed circuit wind tunnel is very important, because in small laboratories we are using the open circuit wind tunnel, but nowadays they are mostly in large laboratories and small laboratories they are mostly using closed circuit wind tunnel. Okay, let's see why they are using closed circuit wind tunnel over open circuit wind tunnel. In open circuit wind tunnel, the cost is very low, the construction cost is very low, but in closed circuit wind tunnel the construction cost is very high. But the flow quality which is very important when you are dealing a wind tunnel is very poor in open circuit wind tunnel. The reason is, when you are sucking the flow from the atmosphere, which means outside the wind tunnel, so the flow will not be a pure flow. The flow will be turbulent. So whatever you are converting turbulent into laminar flow, which is going to the test section, will not be a pure air, will not be a streamlined flow. So we have to make the flow into fully laminar. That is possible only in closed circuit wind tunnel. So the flow quality will be very much quality in your closed circuit wind tunnel. Then operating cost is very high. The operating cost is very high. Here the operating cost is very low. in our closed circuit wind tunnel. Then another main disadvantages in open circuit wind tunnel. The another main disadvantages in open circuit wind tunnel is the operation will be very noisy. So if you are having this open circuit wind tunnel in a small laboratory, the noise which will be very high, very high when compared to closed circuit wind tunnel, because we are getting air from the atmosphere, which is purely a turbulent flow. So whenever the turbulence is higher, the noise will be higher. Okay, because the turbulence is directly proportional to double of the noise. Okay, but in closed circuit wind tunnel, so we are sending a only pressurized air, so there will not be any kind of noise will be created in closed circuit wind tunnel. Next classification is based on test section. Based on test section, the wind tunnel can be classified into two types. So one is open section wind tunnel, the another one is closed section wind tunnel. So the concept is very easy because the same as open circuit and closed circuit wind, but here based on the test section. The open test section, here you can see a car is investigated about the flow properties in open atmosphere. So this is fully open atmosphere, but it is only a test section. So whatever you are seeing in the picture is only a test section. So here also you can see the flow visualization is done in a car. So this flow visualization will be done in a test section. So this whole area is a test section which is open, fully open. Okay, so not same as your closed circuit wind tunnel or closed test section. So let's see the closed test section, which is directly opposite to the open circuit wind tunnel. Here the test section will be fully closed. So here you can see this test section is fully closed here. So that is nothing is open to the atmosphere. Whatever the model to be tested in this wind tunnel has to be placed here only. So if it is a airfoil or if it is a prototype of aircraft, so you have to be placed inside this closed section only. So that's why it is called as closed section. You can see here the stock boundary layer will be there. Okay, in the leads of supersonic separation. So there is not a major problem in transonic wind tunnel, but it is a very major problem in supersonic wind tunnel, because when the shock wave production happens, it definitely disturbs the flow which is coming to the test section. So these supersonic wind tunnels are specially made to eliminate the shock waves. So here the Mach number will be 1.4425. So we can use this wind tunnel for the Mach number up to 5. The last one is, and the very large wind tunnel is called as hypersonic wind tunnel. Why it is large is the Mach number will be above 5.0. As I told you already, when the Mach number increases, definitely we will face some shock waves. So the wind tunnel must be designed in order to eliminate the shock waves. So here in the super hypersonic wind tunnel, so you can eliminate the shock waves very easily. So we can use this wind tunnel for the Mach number above 5.0. So you can use any ideal gases here. So that's why it is called as I have given no longer be treated as ideal gases. The next types based on purposes. The wind tunnel can be classified into many types based upon the purposes. So you can use a wind tunnel for your own purpose. So you can classify the wind tunnel based upon this. So here I have given you some examples here. High Reynolds number. So wherever you want to have high Reynolds number, you can use that. Then V-stall, S-stall. V-stall we know, right? Vertical takeoff and landing. Then S-stall means short takeoff and landing. So you can, if you want to investigate a vertical takeoff, that is a short takeoff, you can use the wind tunnel that is called as V-stall, S-stall wind tunnels. For example, helicopters. So you can test the helicopter in this V-stall, S-stall wind tunnels. So then free flight wind tunnels. Whenever you want to have a free flight, you can use the wind tunnel. Then propeller tunnel. Then birds insert. So this is a different wind tunnels. So if you want to investigate when a bird is hitting on your airplane, so if, what about the impact strength, then you can use this birds and insect wind tunnel to find out the effect of bird is hitting to a airplane. So you can use this. And then solar collectors you have, then low turbulence tunnel, icing tunnel is also there. So there are many wind tunnels based upon purposes. So let me give you some other wind tunnel which is not mentioned in above types. So first one is shock tubes. So as I told you already, when the speed increases, shock wave definitely will be introduced in the wind tunnel. At the same time, when a speed increases, temperatures also increases. So when you want to investigate a wind tunnel with a high temperature, you can use these shock tubes. Okay, so this is our specially designed wind tunnel which is definitely used for high temperature. Okay, so it is a widely used in large laboratories. So shock tube wind tunnel. Then bloated wind tunnel. So this is a type can be used in all the wind tunnels. You can use this blowdown type. This is not a type, so it is a variety. Okay, you can say it is a variety. So what is a blowdown wind tunnel? So in the before wind tunnels, what we saw is the test section will be placed before the driving unit. For example, if you see subsonic wind tunnel, the test section will be placed. This is our wind tunnel means, okay, this is our test section. Okay, so we will be having a driving unit at the end of the wind tunnel. Okay, so but in our blowdown tunnel, so this is our test section means there will be a driving unit ahead of the wind tunnel. This means upstream of the test section. So that's why it is called as blow down tunnel. The blow the air will be given down to the test section. So this is called as a blow down tunnel. So it is mostly used in high speed wind tunnels. So this is automobile tunnel. So whenever you want to investigate a car, you can use this cars. You can use this automobile tunnels. So in automobile industries, they are using this automobile tunnels. It's a very useful for you to investigate the flow over the car. Then environment tunnels. So if you're having any construction, if you want to have any big buildings, means you can use this environment tunnel for investigating the flow or investigating the anything, any properties which is acting on the buildings what you are constructing. Water tunnels. So these water tunnels are specially designed for investigating the submarines and some other uh, vehicles which can be used in water. So thank you all for watching this model. So see you all in the next model. Thank you.